Welcome, everyone. Today we're going to walk through Zscaler for Users, the portfolio that brings zero trust to end users wherever they happen to be working. Whether you're preparing for the ZTA exam or trying to better understand how Zscaler's three core services work together, this presentation is designed to give you a clear, thorough understanding of the platform. We'll cover ZIA for Internet and SaaS access, ZPA for private application access, and ZDX for digital experience monitoring. Let's get started. So what exactly is Zscaler for Users? Think of it as an umbrella portfolio that packages three distinct but tightly integrated services together. The whole idea is to follow the user, whether they're sitting in the office, working from a coffee shop, or connecting from a branch location. Zscaler for Users applies consistent zero trust security and policy. The three pillars are ZIA, which handles Internet and SaaS traffic, ZPA, which replaces VPN for private application access, and ZDX, which monitors and diagnoses the digital experience end-to-end. From a ZDTA exam perspective, these three are your core focus areas. You need to understand not just what each one does individually, but how they interoperate on the Zero Trust Exchange platform. Before we dive into the individual services, let's set the context. In a traditional network security model, users, especially remote users, would have their traffic backhauled through a corporate data center to be inspected before going out to the internet. This is slow, expensive, and doesn't scale well. And for private apps, VPN puts the user directly on the network, which is a major security risk because if a device is compromised, attackers can move laterally to other systems. Zero Trust flips this model entirely. Every connection is intercepted at the Zero Trust Exchange, identity is verified, device posture is checked, and only then is access granted, just to the specific resource, not the entire network. No more implicit trust, no more backhauling, no more open network access. Let's start with ZIA, Zscaler Internet Access. ZIA is all about securing what goes out, the internet browsing, the SaaS apps, the cloud services your users access every day. It acts as an intelligent, cloud-based security gateway that sits between your users and the internet. When a user opens a browser and goes to any website or SaaS application, that traffic flows through ZIA. Every connection is terminated at the Zero Trust Exchange, where policy is applied, threats are detected, and DLP rules are enforced, all before the connection reaches its destination. Because ZIA is cloud-native, there's nothing to backhaul. Users get fast, direct-to-cloud connectivity with enterprise-grade security regardless of where they're working from. This is almost always the first Zscaler service organizations deploy as they begin their zero trust journey. One of ZIA's most critical capabilities is traffic inspection, and this goes beyond just looking at HTTP traffic. The reality today is that the vast majority of internet traffic, including malicious traffic, is encrypted using TLS. If you can't see inside that encryption, you're essentially blind to most threats. ZIA can decrypt, inspect, and re-encrypt TLS traffic in real time, completely transparently to the user. Administrators have flexibility here. You don't have to inspect everything. The TLS decryption policy lets you define exactly which categories of traffic get decrypted and which are bypassed for privacy or compatibility reasons, such as financial or healthcare sites. Beyond web traffic, ZIA also gives you deep visibility and control over SaaS applications. Cloud App Control lets you see everything your users are accessing, both the approved apps and the shadow IT that users are accessing without IT's knowledge. You can then apply policies based on application risk ratings, enforce tenant restrictions, and prevent data from ending up in the wrong cloud service. ZIA doesn't just inspect traffic, it actively defends against threats through multiple engines running simultaneously. Advanced Threat Protection handles known malware and malicious URLs. The Cloud Sandbox is particularly important for zero-day threats. Files that have never been seen before are detonated in a safe environment before they're allowed to reach the user. DNS security intercepts malicious DNS queries, which is a common technique used in command and control attacks. And the IPS engine detects and blocks network-level intrusion attempts. All of this is powered by ThreatLab Z, Zscaler's threat research team, which is continuously analyzing petabytes of global traffic to identify emerging threats and feed that intelligence back into the platform. DLP is tightly integrated with all of this. Because traffic is already being inspected for threats, DLP can analyze that same traffic stream in a single pass to detect sensitive data like credit card numbers, PII, or proprietary source code. If a user tries to upload that data to an unsanctioned cloud storage service, ZIA blocks it and generates an alert. One inspection pass. Comprehensive security and compliance. Now let's talk about ZPA, Zscaler Private Access. If ZIA is about securing what goes out to the internet, ZPA is about securing access to what lives inside your organization. Private applications in your data center, private cloud environments, or any internal system. Traditionally, this was done with VPN. The problem with VPN is that it works at the network layer, meaning once a user connects, they're essentially on your network. If their device is compromised, attackers can use that VPN connection to move laterally throughout your environment. ZPA completely changes this model. Instead of putting users on the network, ZPA uses app connectors, lightweight software agents deployed near your applications, that create outbound-only tunnels to the Zscaler cloud. When a user needs to access an application, ZPA brokers a connection between the user and specifically that application, not the network. The application remains completely hidden from the internet. There are no inbound firewall rules, no exposed IP addresses, and no way for an attacker to discover or reach those internal resources directly. Let me walk you through how ZPA actually implements Zero Trust. There are two fundamental building blocks: app segments and access policies. App segments are how you define your applications in ZPA. You specify the FQDNs, IP addresses, and ports that make up an application or group of applications. Then access policies are how you control who can reach those app segments. You can bind specific users or groups, and you can add device posture conditions. So access is only granted if the user's device meets your security requirements, like having the latest OS patch or an active endpoint protection agent. The result is extremely granular, least privilege access. A developer can only reach the development servers they need. A contractor can only see the specific application relevant to their project. And because users never get network access, even if a device were compromised, there's no way for an attacker to reach anything they're not explicitly authorized for. ZPA also supports privileged remote access for administrators, securely accessing sensitive systems through browser-based consoles with full session recording and approval workflows, without any direct network connectivity. One thing that often surprises people about ZPA is how seamless the user experience actually is. Users just open their browser or application and type in the same URL they've always used. Zscaler Client Connector, running in the background on their device, intercepts that traffic and routes it through the Zero Trust Exchange to the appropriate app connector. From the user's perspective, it's no different from being in the office. This same experience extends to OT and industrial environments, which historically have been very difficult to secure for remote access. ZPA can provide secure remote access to SCADA systems, PLCs, and industrial control systems without ever exposing them to the internet. In some organizations, you have specific requirements around data locality. Maybe regulations require traffic to stay within a certain geographic region, or you have latency-sensitive applications that need to be accessed from a nearby point. That's where private service edges come in. You can deploy Zscaler Service Edge software in your own data center or co-location facility, and users in that region will connect through your local private service edge for low-latency access. But all policy enforcement still happens centrally through the Zero Trust Exchange. So we've talked about securing internet traffic with ZIA and securing private application access with ZPA. But there's a third critical question. Are users actually getting a good experience? That's where ZDX, Zscaler Digital Experience, comes in. ZDX is a cloud-based monitoring platform that gives you complete visibility into the quality of the digital experience for every user. It doesn't enforce security policies. That's ZIA and ZPA's job, but it gives you the telemetry and diagnostics you need to ensure that the security infrastructure is delivering acceptable performance. ZDX works by leveraging the Zscaler client connector that's already running on user devices. That agent collects rich endpoint telemetry, everything from CPU usage to Wi-Fi signal strength to network path data, and sends it to the ZDX platform. This data is correlated into ZDX scores, which give you a single metric representing the quality of a user's experience for a given application. When a score drops, you can drill all the way down to pinpoint exactly where the problem is occurring. End-to-end monitoring means exactly what it sounds like. ZDX has visibility from the moment traffic leaves the user's device all the way to the application responding. This is incredibly powerful in a hybrid work world. Think about it. A user calls the help desk and says Teams is slow. Without ZDX, your support team is essentially guessing. Is it the user's laptop, their home Wi-Fi, their ISP, the Zscaler cloud, Microsoft servers? ZDX removes the guesswork entirely. It's continuously measuring latency at every hop along the path, capturing packet loss and jitter, monitoring HTTP response times from the application, and correlating all of that with device metrics like CPU load and Wi-Fi signal quality. The hop-by-hop analysis is particularly valuable. It literally shows you a network path diagram and highlights exactly where delays or packet drops are occurring. This transforms your support conversation from "we think it might be the network" to "we can see the latency spike occurring between the user's ISP and the Zscaler service edge, and here's the data." Root cause analysis in ZDX is really about correlation. No single metric tells the whole story, but when you combine all the data points together, the picture becomes very clear. Let me give you a concrete example. A user reports that Salesforce is running slowly. You open ZDX and pull up that user's experience score for Salesforce. You can see the score dropped at 2 p.m. Drilling in, you see the user's device CPU was running at 95% utilization at that time. Turns out they had too many applications open and the device itself was the bottleneck. You advise the user to restart some applications, and the problem resolves. Alternatively, imagine the device is fine, the Wi-Fi is fine, but there's a spike in latency between the Zscaler service edge and the SaaS provider. That tells you this is outside your control, but you can communicate it to users and potentially adjust traffic steering to route through a different service edge. ZDX also has deep integration with Microsoft Teams and Zoom, where it can capture meeting-level quality metrics, audio quality, video quality, packet loss during calls. For the ZDT exam, you should be very comfortable applying ZDX data to troubleshooting scenarios and explaining how it works alongside ZIA and ZPA. Let's bring it all together. ZIA, ZPA, and ZDX are three distinct services, but they're all built on and delivered through the same Zero Trust Exchange platform. ZIA handles your outbound internet and SaaS traffic. ZPA handles your private application access. And ZDX sits across all of this as your monitoring and observability layer. The common thread through all three is the Zero Trust Exchange, and specifically, the Zscaler client connector running on user devices, which serves as the on-ramp to all three services. When you're designing zero trust architectures or troubleshooting real-world issues, you have to think about how these three services interact. A performance issue surfaced by ZDX might be resolved by adjusting traffic steering in ZIA or by deploying an app connector closer to users in ZPA. Understanding that interoperability is key to doing well on the ZDT exam and to designing solutions that actually work in the real world. If you're preparing for the ZDT exam, here's your cheat sheet. For ZIA, you need to be comfortable configuring and troubleshooting policies, especially TLS decryption policy and how to balance inspection with privacy requirements. Cloud app control and DLP integration are also important topics. For ZPA, focus on the design side. How do you structure app segments for scalability? How do you deploy app connectors for resilience? When do you use a private service edge versus cloud-based access? For ZDX, the exam will test your ability to look at ZDX data and actually diagnose what's wrong. You should be able to read a ZDX score breakdown and identify whether the problem is on the endpoint, network, or application side. The overarching theme across all of these is designing and operating effective zero-trust architectures that solve real-world problems. The exam isn't just about memorizing features. It's about applying this knowledge to scenarios. Let's wrap up. Zscaler for Users is built around three complementary services that together address the full scope of what end users need in a modern, distributed work environment. ZIA secures their internet and SaaS access with comprehensive inspection and threat prevention. ZPA gives them seamless, secure access to private applications without ever putting them on the network. And ZDX ensures that all of this security doesn't come at the expense of user experience by providing the monitoring and diagnostics needed to keep performance high. All three services operate on the same Zero Trust Exchange platform, with shared identity and policy context, which is what makes Zscaler for Users greater than the sum of its parts. Whether you're preparing for the ZDT exam or designing a real Zero Trust deployment, understanding how these three services work individually and together is absolutely essential. Thank you for your time, and feel free to ask any questions.